right, today we're going to be talking about how one singular point can impact the linear regression. So that one single point could make our predictions from our line seem inaccurate, and that causes problems. So you're going to be discovering this through a Desmos activity. And so I'm going to have you come on over here. So I know you want to have your computers out and you're going to open up into Canvas. I'm not sure if this Desmos activity will work on your mobile device. So you do want your computer out on here. All right, so you can see here we are in this week and we are at Tuesday. So you're going to come on to the notes and lecture videos for Tuesday. And we're going to open that up. And at the beginning, of course, we have the information, but we also have a separate notes videos that are on the paper notes that you have in your packet. So if you need to go back and hear that explanation separately and or hear those songs that go with the three main vocabulary words we're going to talk about today, then you can go here. If today, while I'm gone, we will not be doing the three songs that go with these three main vocabulary words, but we'll do that tomorrow. So for now, come on down here to the bottom of that notes and lecture page and find your class period and go in there to join that Desmos activity. All right, so when you do that, you will start with something like this. And so I'm going to pull this up and I'm going to kind of walk you through some of what's happening here. Okay, so at first, and you go ahead and you work while I'm talking, and I'll kind of pause and let you do some typing and fill in some information. So at the beginning, you're just going to be talking about a review of describing the relationship, describing the scatter plots. So go ahead and click on each one of these and or think to yourself how you would describe that and then click on it to see if you were correct. All right, so give you a moment to do that. And then we'll go on to the next slide. And so what we have got here is this is a relationship, and I didn't set up the story here very well. I'll go back and put that in there. But we are going to attempt to predict how much fat is in a granola bar just by knowing the general component of its calories. So we're trying to see if we can't see what the subgroup of fat content is based on just the overall total from its calories. And so you're asked here to describe the relationship, just direction, strength, form. Are there any unusual features or outliers and that kind of thing? And at this point, you don't know about unfeatured or unusual features or outliers. So there are none of those. Okay, so you've got that in there with your context. So real quickly, I want you to take a look at this matching you're going to do. And you're going to decide, you've got these different correlations. We'll go ahead and show you those values. So go ahead and pull those correlations up. Let me give you about a minute maybe to work on those and match up those correlations. I usually like to go negative to positive. All right, so you're taking a look at ones that are not very, the negative strong, the negative weaker, not very much linear correlation, the medium strong, and then the strong positive. All right, so you're going to want to connect all those together and see if you have any matches that are working. All right, I'll let you finish that up. Okay, so Now, while you're finishing that up, I'll go ahead and talk to you about the lesson today. Yesterday we talked about transforming all the data and how transforming all the data impacted if it impacted the slope sign, positive or negative. But then also we talked about how those transformations don't impact the correlation because all that proportionality remains the same around the line. But today we switch over from just general transformations of all the data at once, and that's all we've done so far this year. But now we're going to have an impact on just one singular point. And we're going to see how that one singular point will impact the correlation to the rest of the data. How will it impact the equation of the line? So, on all of these slides, they're all the same topic. They are all about if we can predict that subcategory of fat content, fat grams in the granola bar from knowing the overall calories in the granola bar. Okay, so here is some information. I'm going to let you read this. It says we do have this one granola bar, this one that's this red dot at 210 calories and 11 grams of fat. And it's that point in red. Move that point around the screen. And so that's what I want you to do is kind of move that. And I want you to look at how it is impacting the equation of the line and how it is impacting the correlation coefficient. And since once you move it, then you don't really have a way of doing a reset on all of these screens, I included what the original equation was. So you can see this started out as predicting the fat grams was 0.065 times the calories minus 4.5. And then it had an original correlation coefficient of 0.926. So I can see where I have my point now. It has made it weaker. So on all of these slides, I give you the original information so that you can reference that when you make changes to see how they impacted the slope, y-intercept, and the correlation coefficient. All right. So now it says, describe what changes you observe in those values. So just make some general statement about what you notice is happening as you are moving your point around. You can go ahead and type that in and submit that. All right. So now we're going to have 3 main vocabulary words today. And the first one is called leverage. And so we're going to talk about what having high leverage does, what high leverage is, what leverage is in general, what high leverage is, what low leverage is, how those impact the equation, correlation, those things. All right. So I tell you what, we'll just go ahead and go through here with the definition. So we have this new topic of leverage. And so on each time we start a new topic or a new word, I'd say the definition. So a data point whose x value, so here in the x direction, is far from the mean of the x's. So let's think about our domain here. If I was to guess where I think that the mean of the x's is, then it's probably right here somewhere it's generally in this vicinity, maybe 130, 140-ish, maybe 100, yeah, probably 140-ish. That would be the mean of the x's, okay? So if I was to, there's our mean of the x's. And so a data that has high leverage is a point that is far away in the x direction. That's leverage. Like a lever. So, or like a lever, I guess you say in science, I don't know. And so you can see it's this thing that makes something teeter-totter, and it's going to teeter-totter around. It's actually going to teeter-totter around that mean point. Because remember, we talked about how that mean point is always a point that's on a line. We had talked about that in day 5's lesson. So I want you to place the blue highlighted point in a location that has these qualities: high leverage, and does not significantly change the slope or intercept. And for reference, here's what the equation of the line was. Remember how we discussed that idea of extrapolation? And so, if you remember, when we talked about extrapolation, we said, hey, right here in this section, so I'll kind of let you visualize it. In this section of the data, that's where our equation was created from, the least squares regression line. This one that's the 0.4645 slope minus 4.5. Okay, so there's my correlation. If I move this point far out here with high leverage, and I still am on the equation of the line, then the correlation gets stronger. And here's why. That point being farther out here in the domain, in the future, in a higher calorie granola bar, verifies that, hey, over here in this small section, not only is the linear relationship happening in this vicinity here in this domain, but this point, this piece, this granola bar here verifies that that trend continues for a larger domain. So if that trend continues, and so now I have a larger domain for which I know this linear relationship is happening, therefore, stronger linear relationship. So that's what's happened. So that's important for you to know. If I have an additional point, a point that has high leverage, and it is reinforcing the original data line, then that correlation strengthens. Okay. All right. So that was one big idea there. Now, take a look at this. This is like the other one started. So go ahead and now move this point to have high leverage and make it be such a point that does change the slope and the y-intercept. So investigate that. And so discuss, type in there, how does that correlation coefficient change? Okay, it changed a whole lot. All right, so it changed it a lot. So discuss how it went from 0.926 to whatever you changed it to. All right. I think was there another question there? Yeah. Okay, so then you can write your point that you chose there. You might put it in an easy spot there, like 301 or 300, 1. Okay, moving on. All right, so now here's a couple true falses that I want you to answer. A point that has high leverage, that's what we've just done. We did a high leverage point here on slide 6 and a high leverage point here on page 7. And then this question, true, false, answer it and explain your choice. Okay, so now we've dealt with high leverage, but now we're going to address this idea of a point that has little to no leverage. So the blue data point in this location here on this screen is the point it has the least leverage possible. And the reason for that is because I actually placed that point at the mean of the x's. It happens to also be at the mean of the y's, the center of the y's. So I put that point right there on purpose because I calculated what the mean of the x's and the mean of the y's was. So I want you to move that data point straight up and down and see what happens to that slope. You got to be real careful. Move it exactly straight up and down and see what happens to the slope, how much it's changing. Is it way impacting it? How much is this y-intercept changing very much? And then what's happening to that correlation coefficient? Again, I have the original values over here for reference. The idea is that the slope and the y-intercept didn't change too much, but that correlation did. So look here. Points, here's true, false. Points that have low leverage will not have a significant impact on the slope and the y-intercept. Is that true or false? Okay, so you could practice that and change that. Moving on. Points that have low leverage cannot have a significant impact on the correlation coefficient. Okay, so what do you think about that? All right, okay, so that's the end of leverage. Leverage, that point that is far away in the x direction. Low leverage, high leverage, it can be out of whack or in line. In both cases, there's a high leverage in line and out of whack. Here's a low leverage in line and out of whack. So we were discussing how those change. All right, next new topic, influential point. Influential point. So here's the definition. If you remove this point from the data, a point, you remove a point, and it really impacts, it's really having an impact and makes a very different regression line, then that point is considered influential. In particular, we're really interested in if it is changing the slope. Okay, that's the one that we're more interested in than the y-intercept. Because, remember, the y-intercept sometimes doesn't even make sense in context of a problem. So we don't get bent out of shape with the y-intercept changing very much, but we do with that slope, because that's that relationship that we're really interested in learning about. Okay, so on this graph, move a point to have the following qualities. Okay, so pick any point in here. You can pick any of the points you want. And so then I want you to move it so that it has high leverage and it is not influential. Okay, that's the quality, new word, not influential. Okay, so what would that be? Since the point is not supposed to be influential, then that slope and y-intercept should not have changed very much. However, describe what happened to your correlation coefficient. Okay, so you're going to find a lot of these slides actually are very similar to what we've already done, but I'm using different vocabulary. Okay, so that's what I'm doing is I'm infusing the vocabulary and the context of this language by doing the same activity, just using different words to describe it. Okay, so here we have another one. Here's the equation of the line. There's its correlation. Okay, so remember, influential point, impacting the slope, in particular the slope. Okay, here we go. On the graph, move a point to have the following qualities. High leverage is influential. All right. So you should have done one that's far away from the mean of x, that's high leverage, and being influential, impacting the equation of the line. Okay. All right. I'll reset that. And moving on. Okay. So here we go. Interesting. Okay. So now here's another vocabulary on this graph. Move a point to have the following qualities. Choose a point with basically no leverage. Okay, what would that be? Where is that going to be? A point with basically no leverage. Okay. And move that point straight above and straight below. So thinking that point with low leverage somewhere, remember, has to be somewhere in the mean of x and the y, little to no leverage, somewhere in here. You're going to move it straight up and down and see how does this equation change? How does the slope and the y-intercept change? How is the correlation going to change? Describe the change to the equation of the line in particular. Was that slope significantly impacted? And then come on down here and describe what happens to the correlation coefficient. All right. And, okay, this one is different. We have not seen this one before. So let's take a look at this. I'm on slide 15. On the graph, move a point to have the following qualities. Choose a point, we want it to have high leverage. Okay, so it's going to be far away from the mean of x. But we want it in the lowest values of the domain. So as close to 0 as we can get. So outside of the data, but as close to 0. Okay. So I'm going to pick something like here. I'll scoot it on over as close to the y-axis as you can. Okay. So Now move it straight up and down. I want you to understand this is really important. I'm pulling this up, but what is it actually doing to the slope? Here I am pulling this up, it's this back end. So do you see how this line is toggling? I want you doing the same thing. See how it is toggling around the mean point? Because that mean point is always a point that's on the line. So it's toggling around that mean point, and it's to the left of that mean point. So therefore, when I go up, it's pulling that back, the left side up. So when I move this point up, it's pulling the left side up, okay? As opposed to if I'm here on the right, then if I go down, it pulls the slope down. If I go up, it pulls the slope up, okay? And that was because I was on the right of the mean point. I was over here on the right, but we haven't seen this. If you're on the left, when you pull the left up, it pulls the left of the point up, making it actually a flatter slope. Okay, so get that figured out. Understand that behavior of that line. What happened to that slope? Got flatter, slope, whatever, and how did that correlation change? All right, moving on. What kind of relationship do you notice between these points? Are they that are influential and have high or low leverage? Okay, so I'm on slide 16. I want you to think about that. Which points tend to be the ones that are influential? High leverage points or low leverage points? New topic. Okay, third vocabulary word of the day. Here we go. Outlier. Well, you say, what? Ms. McClellan, hello. We've been talking about outliers forever. Yes, we have. Okay, but we have not talked about outliers in terms of two variable equations. We have not talked to them about linear regressions. What do outliers look like in that regards? Okay, so it still is based on this idea. Definition, here we go. Any data point that stands away from the others. Okay, I get that. That is more than 2 standard deviations of the residuals. Important. 2 standard deviations of the residuals. So remember how in this direction, how far the actual y is from the predicted y. 2 standard deviation of the residuals away. We had talked about that a couple of days ago, standard deviation of those residuals. So that means technically an outlier is in this y direction. It's not in this way. This is not this. This is what kind of blows your mind. That orange point right there is not considered an outlier because it is in line with the rest of the data. It has high leverage, but it's not considered an outlier. Okay? That's where this vocabulary can get jumbled up. So, once again, high leverage, but not an outlier because it stayed in line with all the rest of the data. So, then what's an outlier? Let's look. It's unusual in that y direction. Move this given point around so it makes an outlier. Notice what happens. Okay, so here we go. Something like this. You see how it is now far away from that trend in the y direction. Here's an outlier. Here's an outlier because it's far away in that y direction. Here's probably an outlier far away in that y direction. This is an outlier. This is an outlier. Of course, you can't have negative fat grams or else we'd be millionaires doing things with negative fat grams, okay? So in that context, you can't be down here. But anyway, you get the idea. Outliers are in this Y direction. High leverage are far out in this X direction. Okay, all right. Moving on. Slide 18. Okay, here we go. So now, move the orange data point to have the following qualities. Has little to no leverage. Okay, so think little to no leverage. Is an outlier. Place that point somewhere. Okay, secret or like hint, it's not really changing the equation of the line very much. It's not affecting the slope. But let's see here. Here was a correlation of 0.9 strong. What's happening to that correlation? Holy cow, look right there. That's definitely changed, even though the slope and the y-intercept didn't really change. Okay, so write up what's happening there. Again, getting all that vocabulary. Okay, that was slide 18. Ooh, okay. Now, we've done the same kind of thing over and over again. We've really infused outlier vocabulary, leverage vocabulary, and what was the other one? Influential point. Okay, but this is a real interesting one. I like this one. Okay, so here we go. So here's another unusual situation. So now look at this equation. We've got something very different than we've seen before. We actually have one that has little to no correlation. So that's like saying, what if calories was not a predictor whatsoever of the amount of fat that the granola bar had? Okay? Fat chance. All right, pun intended. Okay, so what if there was not really much? Look at that, pretty much zero correlation. Look at that correlation. It's like nothing going on. Okay, here we go. All right, now suppose also, so here we have little to no correlation, that we have this granola bar. There's a magical granola bar. Okay, maybe it was made in the Willy Wonka chocolate factory. Magical granola bar, whatever. Okay, and it basically had no fat, but 350 calories. That probably could happen because you could have like almost all sugar. I don't know how you'd have that with a granola bar, but anyway, okay, so place this point. Here we go. Has high leverage because it is far away from the mean of X, high leverage, and outlier, kaboom, right down there. 350 calories with basically zero fat grams. That's an outlier. But whoa, holy cow. I want you to study what has just happened to that slope and the y-intercept and that correlation. Okay. For reference, I put what the original slope was 0.01. Look at what you got now. The original y-intercept 17.68. Look at what you got now. The original correlation was super weak. Now, that one particular point was so influential that dare I say this was positive, strong, negative correlation? Holy cow. What is going on? One singular point, so influential, it made something that had no correlation whatsoever, or weak, very weak, look like it had a strong negative correlation. Whoa, big deal. Okay, so all that vocabulary going on together. So let's think residual. Okay, so remember that residual is how far away that the actual y is from the predicted y from that LSR. Okay, so look at this little residual here. I mean, it's not got much. It was so impactful of a line. point, so impactful of a point, it pulled that equation to it. In fact, I think some of these other points over here would have a bigger residual than this one right here. So I wouldn't say that's a very large residual. Some of these ones over here have a bigger residual than it. So impactful, it made hardly any residual at all. Interesting. So go ahead and write something like that. Okay. I like to do this one. This one's my favorite one. Okay. So pretend new context, but we're going to use the same graph. Okay. So let's say that we have this context here where we have shoe size and IQ, your intelligence quotient. Okay, so what do you think about that? In general, do you think that your shoe size is a good predictor of your IQ? Okay, I'm going to have to say probably not. Probably there's little to no true correlation between shoe size and IQ. All right, but watch this. Bozo the Clown, he comes along, and he has a gargantuan foot. You know those big old floppy feet, huge. Okay, he's got a huge foot, and you think Bozo the Clown is some idiot? And no, sir. Bozo the Clown is a freaking genius. His IQ off the charts. So we're going to take, here's Bozo the Clown, our orange point. He's got a huge shoe size and he's a freaking genius. So now, bam, look, we took something that had no correlation, little to no correlation between shoe size and IQ, and that one person, Bozo the Clown, made it look like there's a strong correlation, 0.884, between your shoe size and your IQ. Strong positive linear relationship. So you have to watch out for that single point because that single point can be so influential that it takes something that doesn't have a correlation and makes it look like there is one. So, hopefully, by doing this Desmos activity, you've had a little experience and you feel like you can kind of get how to represent lines and your least squares regression line based on how those points change. But I'm going to help you with that. And so, let's go ahead and go on over to your page 50 and take a look at that. And here we go. So we want to draw a line of best fit. The dashed will be one without the unusual point. So if I take a look here, there would be what the line would look like without the unusual point. Okay. Now, but then I have this unusual point in here, right there. Okay. Remember, your line has to toggle through that mean point. So I want to give you this kind of idea of let me in fact I'm going to put this line in here like this. Okay, so this original point was kind of going like this. Let me put it in here. Okay, shift it, pull that up. Okay, here we go. So there's kind of that point. All right, so then this solid line, remember, it has to go through this mean point. So it's really got to toggle like this. Okay, it does not, word of warning, it does not anchor from your y-intercept. Does not anchor from the y-intercept. It toggles through that mean point. Now, I don't know how much that point's going to move it. Probably something about like this. Okay? I honestly, I don't know how much it's going to change that point. If it's going to toggle it, it wouldn't really pull it all the way up that much for sure. Okay? But I can tell it's over here to the right of the middle. So it's going to pull it up here on the right. Okay? And so if you need to stop and you can't pay attention to what's going on to these lessons, I'm going to keep going through all of these. So if you want to, when you get home, sit side by side with the homework and see my discussion of what these lines probably would go to, then I'll continue this video, but you can just scroll forward and see what you think these lines should go through. Okay, so here comes this one. I'm going to draw, here's kind of what the dotted line of best fits would look like with this. Yeah, probably something like this. Okay, it's going to toggle through that mean point. So because it is to the right of the middle, then it's going to pull this up here. So that point pulls the slope steeper. And so then look at what the question, it says, if your point were removed, if the unusual point is removed, then it would make this line go back down on the right. If the point were removed, then it would make this point go back down on the right. That's what's happening. Okay, here's this next one. Here comes our dotted line. Probably our line of best fits, probably something like that. But let's look at what happens with this point. We've got this line, and the important thing to know on this is that this dot here is to the left of the middle. It's to the left of that middle. So therefore, it's actually going to pull this guy and toggle him up on the left side of the middle. So the left will go middle. So he actually makes that slope go down. The slope decreases because you're pulling the left side up. Okay, so that's kind of the idea of what's happening. Now this guy right here, see, in his original form, I think he's going to be about like that. But then I'm going to go put his solid line in there. So I think that point, because it is to the left of the middle, then he's kind of pulling this line down on the left side towards him. So then look at what's happening to that slope. So here's what he's doing. Remove him, and then that's what it takes it back to. Okay, let's scoot on down here. And again, let's put in our dotted line. Oh, interesting. Look at what these guys are doing. These points look to be already in line with it. So I don't think they're going to be changing much there. So I'm just going to leave that and let you be. Now, remember what, according to our Desmos lesson, it does to the correlation. He extends the domain, so it actually strengthens that correlation. And so removing it would weaken that correlation, okay? And then here's this last one here. We've got our dotted line. So let me put our little dotted line in. There's without the point of the equation of the line, and he is right of the mean point. So he probably makes that happen. So removing that point makes that slope, go back up. He is causing that to go down. Removing it makes that slope go back up. All right, so there's just some ideas of what's happening with that. And so then on your assignment, you're going to be doing the free responses as well. Hopefully you've got an intuitive understanding of what's happening with all those values. And so there is your very long video, but if you've needed to go in your own time and watch the end of it, then that's fine. All right, I hope that helped.